NASA's Voyager 1 spacecraft, currently the farthest human-made object from Earth, has fascinated the world for nearly 5 decades. Since its launch, Voyager 1 has transmitted invaluable data from the fringes of deep space, dramatically expanding humanity's understanding of the cosmos. Recently, however, the spacecraft transmissions have shown strange irregularities, baffling anomalies that have sparked intense debate among scientists. Are these just technical glitches, or could they hint at something far more extraordinary? Perhaps even extraterrestrial in origin? Join us as we explore these puzzling signals and consider what secrets may lie hidden in the vast unknown. Humanity's innate curiosity has always driven our desire to explore the universe. This spirit of discovery paved the way for landmark missions like Pioneer 10 and 11, trailblazing projects that laid the groundwork for even more ambitious ventures. On August 20th, 1977, Voyager 2 launched from NASA's Kennedy Space Center, ushering in a transformative era of space exploration. Just weeks later, on September 5th, Voyager 1 followed, embarking on a historic journey past the outer planets that would forever reshape our scientific perspective. Weighing about 721 kilograms, comparable to a small car, each probe traveled distinct trajectories at different speeds. On December 15, 1977, Voyager 1 overtook its twin in distance thanks to its faster route, and from that point forward, it became a critical instrument in unraveling the mysteries of the universe. Before we dive into its latest discoveries, it's worth revisiting some of Voyager 1's earlier milestones. In 1979, when it was roughly 265 million kilometers from Earth, the spacecraft captured stunning high-resolution images of Jupiter. In January of that year, it conducted a 100-hour-long observation that resulted in a time-lapse video revealing the planet's swirling atmospheric patterns. Voyager 1's 3,750 images delivered an unprecedented look at Jupiter's dynamic weather systems. During this mission, it also discovered a previously unseen ring around the planet and identified 2 new moons, transforming our understanding of Jupiter's complex system. To ensure safe passage and avoid a collision with Titan, Saturn's largest moon, Voyager 1 executed precise course corrections. Afterward, its mission extended beyond the planets, propelling it toward interstellar space at an astonishing rate of 325 million kilometers per year. In January 1990, it officially entered this new phase, conducting landmark studies and capturing historic images. Among its most iconic achievements was the family portrait taken on February 14, 1990, from approximately 6 billion kilometers away. This mosaic of 60 photographs included stunning views of the inner planets and became one of the most symbolic moments in space exploration. These images were added to an already vast collection that included hundreds of photographs from the probe's encounters with gas giants. Meanwhile, Voyager 2 was breaking new ground of its own. It measured wind speeds on Neptune that topped 2,100 kilometers per hour, about 1,300 meters per second, the fastest atmospheric winds ever recorded in the solar system. It also explored Neptune's moon Triton, where temperatures plunged to an astonishing minus 391 degrees Fahrenheit. Triton surprised scientists with active geysers ejecting nitrogen gas and icy particles up to 5 kilometers high, suggesting a far more dynamic geological system than previously believed. These groundbreaking discoveries from both Voyager spacecraft forced scientists to reconsider long-held assumptions about the solar system. Moons once thought geologically dormant were suddenly alive with activity. The legacy of these missions continues to shape how we explore and interpret the cosmos today. Earlier theories about planetary geology were transformed by the Voyager missions, especially Voyager 2, which made history as the only spacecraft to visit both Uranus and Neptune up close, an achievement unmatched to this day. NASA extended the mission's lifespans by cleverly conserving energy, such as shutting down non-essential systems. Both spacecraft are expected to operate until around 2030, marking the end of an extraordinary era for the dedicated teams behind them. Voyager 1 and 2 were engineering marvels. Their slow-spin design reduced motion blur and captured images. Even before reaching the outer planets, they began transmitting stunning photos of Jupiter, revealing its swirling clouds and the iconic Great Red Spot, a giant storm that has fascinated scientists for decades. One of the most groundbreaking discoveries was active volcanism on Io, one of Jupiter's moons. Instruments detected unusual signals that were later confirmed by images showing towering volcanic plumes and a reshaped landscape. One eruption was 1,000 times more powerful than the Mount St. Helens explosion, covering an area nearly the size of France. As the mission progressed, systems were gradually powered down to preserve energy for interstellar travel. Due to technical limitations, Voyager did not capture photos of Mercury or Mars. Later missions, such as Pioneer 10, Pioneer 11, and New Horizons, built upon Voyager's legacy. On February 17, 1998, Pioneer 10 overtook Pioneer 11 in distance from Earth, but Voyager 1 went even farther, officially entering interstellar space on August 25, 2012. A key to the mission's success was the use of gravitational slingshot maneuvers. Rather than relying solely on propulsion, the spacecraft used the gravity of planets to gain speed and adjust course, saving enormous amounts of fuel. Jupiter's gravity, for example, gave Voyager 1 a critical boost, and similar maneuvers by Voyager 2 around Jupiter and Saturn enabled it to reach Uranus and Neptune. Researchers continue to study Voyager 1's recent mysterious signals from deep space with anticipation. Meanwhile, both probes have gathered invaluable data from the fringes of the solar system. On Jupiter, Saturn, Uranus, and Neptune, Voyager 1's time-lapse photography revealed 10 volcanic eruptions on Jupiter, uncovered more moons, and discovered a previously unknown ring. It also found four Saturnian moons, Mimas, Enceladus, Tethys, and Rhea, while capturing striking images of the planet and its rings, shedding light on its complex structure. The flybys of Uranus and Neptune provided essential data on their atmospheres and moons, deepening our understanding of the solar system's distant reaches. After completing their planetary tours, both spacecraft set course for interstellar space, where they continue to transmit scientific observations from the farthest frontier. As the world awaits further insight from Voyager 1's enigmatic transmissions, the mission remains a source of inspiration. These legendary journeys continue to captivate scientists and space enthusiasts alike, offering unprecedented views and groundbreaking discoveries that have forever expanded our understanding of the cosmos. Achievements. The Voyager spacecraft each carry a remarkable cultural artifact, the Golden Record, designed to share Earth's story with any intelligent extraterrestrial life they might encounter. This interstellar time capsule features greetings in 55 languages, a curated collection of music from around the world, and natural sounds such as rainfall and whale songs. It symbolizes humanity's hope that advanced civilizations might one day find and comprehend this message from Earth. Voyager 1 and 2 were also equipped with an advanced array of scientific instruments that transformed our understanding of space. These included magnetometers, plasma wave detectors, and high-resolution imaging systems, all of which produce groundbreaking data about the outer solar system. The magnetometers map the magnetic fields of the outer planets and their interactions with their surroundings, while plasma sensors shed light on how solar winds influence planetary atmospheres. One of the mission's most significant scientific achievements was mapping the boundary of the heliosphere, the vast bubble of solar particles and magnetic forces that surrounds our solar system. As Voyager 1 neared this edge, it detected a transition from particles of solar origin to those from interstellar space, providing crucial evidence of how this boundary shields Earth from harmful cosmic radiation. The spacecraft also pinpointed the termination shock, the region where the solar wind slows and becomes denser, followed by the heliosheath, a turbulent zone where solar and interstellar materials interact, creating a dynamic plasma environment. Voyager 2 added even more depth to our knowledge of these distant regions. Its observations of Uranus, especially the planet's oddly tilted magnetic field, challenged existing theories and spurred new investigations into planetary magnetism. Beyond their scientific legacy, the Voyager missions captured the public's imagination. Their vivid images of distant worlds, from the dazzling rings of Saturn to Jupiter's swirling great red spot, have become iconic, inspiring generations to look up and wonder. These missions are not only milestones in space exploration, but also enduring symbols of human curiosity and creativity.